Hey, what's up everyone? It's Mr. Lang. In this video I'm going to be taking you through one question on this real world functions worksheet. I'm going to do question number 5 with you guys. I think you'll be able to handle all the rest. And in fact, you'd probably be able to handle number 5 on your own. But I just want to make sure it's solid. And if you want to do the question ahead of time and then just check your work with the video here, that's cool too. So anyway, let's get to number 5. Alright, so we have a graph. On the y-axis is the height in meters, and on the x-axis it's the time. So it's actually, we'll say this is the t-axis. So let's see what they're talking about here. It says the following graph represents the height above the ground versus time at a resort as Thomas rides his favorite ski slope. So he's skiing, and you can probably make a guess on what's going as the height goes up and then how it kind of like wavers down. Anyway, let's start with question A here. It says state the domain and in your own words what the domain represents. Well, the domain, remember, is all the possible x values, or in this case the t values. So the time starts at 0, time can't be negative, and it goes all the way to 6 where his ride ends. So our domain is from 0, so it's greater than 0 but less than or equal to 6. So there's our domain. And as far as what it represents, it means the ride length. So the total ride length. And I guess when I say ride here, it's kind of a weird way to talk about skiing, but he's got to go up probably the chairlift here and then back down. So I guess you can consider the whole thing a ride. I guess that's what I mean. One run, I guess, would be more a better term. But anyway, you get the idea. As far as the range, so state the range and in your own words what the range represents. Well, the range is all the possible y values. In this case, it's the height. So the range is from 0, and it looks like he reaches a height of, this counts by 10, so 90. So it's greater than or equal to 0, and instead of y, I'm going to say h of t. You could probably say y and be okay, or maybe just even h, but I think this is the best way to do it. And it's less than 90. Less than or equal to 90. What this represents is he gets to a maximum height at 90 after starting at 0. So I'm going to write that in. So he started 0 feet off the ground and reached a maximum height of 90 feet. All right. Part C, it says, what might Thomas have been doing for the interval 0 to 2? All right, let's start with that. So 0 to 2, it's a really steady climb. So like I said before, I bet this is the chairlift. So I'm going to say that. So from 0 to 2, he was riding the chairlift up the slope. Now his average rate of change, going ahead here, second part of this question, his average rate of change, remember average rate of change means do the slope formula, all right? So the average rate of change, you're going to use the slope formula. And remember that's m is equal to y2 minus y1 over x2 minus x1. And so from 0 to 2, the first point is 0, 0. And at 2 seconds, this is the point 2, comma 90. So the average rate of change, so I'll do average rate of change. This is going to be, if I start with the y's, 90 minus 0 over 2 minus 0. Well, so that would be 90 over 2, which would be equal to 45. So the average rate of change is 45 meters for every minute. So I'll say meters per min. And so we use proper units there. All right. Part D. What might Thomas have been doing from the interval 2 to 6? What was his average rate of change? And then we'll compare it to what we found in C. So let's start from 2 to 6. It's kind of not quite constant like it was riding the chairlift up. So this is where he was skiing down. So I'm going to say that. And the second part of this question is, what is the average rate of change? So we got to find the average rate of change from here all the way back down to here, which would be at 6, 0. So I'm just getting that ready. All right. So what might he have been doing from 2 to 6? That's when he's skiing down the hill. And the average rate of change in this case, let's see. Well, it's going to be, I'm going to use this one as my y2, so it would be 0 minus 90 over 6 minus 2. And I wrote m here, average rate of change. It's all good. All right, so let's see what we get. We get negative 90 over positive 4. So this is negative, which makes sense because it's a negative slope. He's losing height as he goes. So 90 divided by 4, that's 22.5 meters per minute. So comparing this to what we found in part C, I would say this is half of it. So this is negative 2. This is a negative 22.5 because he's losing. So comparing it, I would say he skis down the slope at half the speed as the chairlift took him up. All right. It's also negative. You could mention that too, but I think we get the picture here. So that was question number 5. Your check your understanding is just to do the rest of this worksheet. There's nothing to do online, so you should be all set. Anyway, thanks for listening.